Hello, my name is Anthony Senft, and this is Physics 2, Lab 3. In this presentation, I'm going to give a brief introduction of this week's lab, followed by a more in-depth explanation of the experiment and the results and the data I gathered from it. Then I'm going to go into a computational model that modeled what happened in the experiment in kind of an ideal situation. And then I'm going to discuss some of the differences and maybe some speculation on what could have happened differently. So jumping right into this, the purpose of this lab was to determine the dependence of the magnetic field due to a bar magnet on distance. Then we're going to compare that value to one obtained using the Biot-Savart law. A little breakdown of the broad system. We have the magnet, the bar magnet is our primary system, and then the surroundings of the recording device, so the magnet's acting on the recording device, or rather the magnetic field. And when all was said and done, I got that the B net is 5.54 times 10 to the negative 5 teslas. So some fundamental principles that are very important in this lab are going to be the Biot-Savart law, which is right down here in these two different forms. The distance dependency on a magnetic field, because that's ultimately what we're trying to determine. And then finally the concept that magnetic fields can be superimposed on one another and either additive or destructive depending on the situation. So in this experiment in particular, we took some measurements from D-perp, so with the cell phone measuring device perpendicular to the magnet, and then from D-perp, where it was kind of at a 45-degree angle. It's important to note that we also adjusted for magnetic north in this lab, and I'll go into why a little bit later. So here's my data. On the upper left-hand side, you can see some of the distance for the on-axis field at different criteria. On the bottom, we have the off-axis. In that first red box up on the top, that's going to be the equation obtained from all this data, and that's modeled in this equation right down here based off of that. And then down in this box in the lower right-hand corner is going to be the results of this analysis. So into some more nitty-gritty analysis and calculations. This is essentially just an algebraic breakdown of what happened. Essentially, we're trying to find this mu. So you have to find a symbolic equation for it. And then you can use that formula given by the plot to obtain a value for mu, as long as we assume that r is equal to 1, because this is pretty much equal to 1. So we get that mu equals 2.5185, and that's going to be used later on in the computational model. So what are some observations in this lab that we can say? Well, all but 2 and 3. So the magnetometer was far away, it measures near 0, and as it moves closer, the component of the magnetic field increases. Now moving on to the computational model. Here up in the top is my equation for determining the dipole of B. So this is just the Biot-Savart law kind of written out in a much larger fashion. Then this is just a scaling factor and a distance that I used from my average distance from that data observed. And then we just have some observation axes being set up. Next, I developed several arrows representing the different magnetic fields at different locations, which will come into play in the model. And finally, the observation at 45 degrees, I set up that angle. So here's what the picture looked like at the end of the day. You can see all those different forces interacting with one another, and it all kind of makes more sense when you look at the data, in my opinion. So moving into the discussion, the computational model, once you added up the B-perp, the B-parallel, and the B45, which I discussed a minute ago, you get that the B net equals 2.21279 times 10 to the 5 teslas. As you can see, that is much, much, much different than our observed data by almost double. So now a little bit of a discussion about what happened. So what if we didn't compensate for magnetic north and laid the meter stick at some intermediate angle? Well, essentially, we couldn't say that we were dealing with strictly B-perp and B-parallel. we would have to account with cosines and sines, and that would just make the math way more complicated. Essentially, the answer probably wouldn't change much, but it would be a lot harder to arrive at. Finally, if I put two identical magnets, well, superposition of magnetic fields, so they would increase the magnetic field strength, and the measurements would ultimately be different and larger, but the process would be the same. All right, that is all I have. Thank you for watching.